Hello guys, welcome back. In this video, if you watch this video, then what you are going to learn? In this video, I want to discuss about ML regression based models evaluation. In ML models, we have multiple types of models like supervised, unsupervised, and reinforcement models are there. Among them, in supervised, we have again two types, that is classification based models and regression based models. If you create a regression based model, then for that model how can you able to perform evaluation, that we will understood in this video by hands on. For regression based ML models, you can able to evaluate those models by using R2 score, and you can also able to evaluate such regression based models by using one more parameter, that is mean squared error. These two methods are present in sklearn, that is scikit-learn. So for this lab or for this demo, I'm going to take a wine data set, and I will do the pre-processing of that data. I will perform pre-processing of that wine data set. In this wine data set, you have multiple columns where you also have one column, that is quality. So what is the quality of wine? Based on other all columns, we are going to predict the output, that is wine quality. For that, we are using a model, that is linear regression. This linear regression model we are taking. After taking this model and training, after taking this algorithm and training this algorithm with that wine data set, we are going to observe R2 score as well as mean squared error to evaluate our model, how our model is working, like what is the performance and what is the error. So when do we say our model is performing good? If our R2 score is, actually our R2 score is in between 0 to 1, where the model can able to perform better. If R2 score is near to 1, R2 score is near to 1, then we can say our model is performing good. Whereas, what does, by using this mean squared error, how can we able to predict our model how much good it is performing? This mean square error will provide us the error of our model, how much error our model is producing. This value is also in between 0 to 1. Since if the error is very less, then we can say our model is performing good, right? Yes. So if mean square error is towards 0, that is how much it is towards 0, near to 0, then that much accurate our model is performing. If R2 score is near to 1, then that much accurate our model performance is. It provides performance, more performance. Whereas mean square error is near to 0, which means less error, that is highly accurate, or you can say less errors, right? Yes, our model is producing less errors. So now in this lab, we gonna perform all these tasks. For this, I'm opening a notebook. That notebook is Jupyter notebook. I have created this notebook by taking an advantage of AWS cloud by using this SageMaker service. Here I created a notebook and now I'm opening that notebook. So that is this. Inside this data files folder, I have stored a file that is wines quality dot csv. So that is nothing but this file. I want to use it to load my data. If you want to load your data, then in order to load our data, I want to use this pandas data frame as pd in order to load my data. Since this is a csv file, you need to use pd dot load csv. Now our csv file will be loaded into our data d variable. You can just print d to see the data, like top rows, top columns, top records, top 5 records. So I think it is running. Yeah, one cell is getting executing. So whenever this file got read, load csv. So no attribute load csv. I think the method name is error. That is a read csv. Yeah, now you can see we have this data. So d will be printed. You can also observe, you can see the number of rows, or you can say records, and number of columns are nothing but number of features. So that also visible here. Let's say I want to see the description of it, like what is the minimum, what is the maximum. So those data I want to see. So I'm using this describe function. There you can able to observe the count and mean, standard deviation, minimum 25% and 50%, 75% and maximum value. So those all will be visible for each and every column. You can say every feature. So d dot info will provide us a bit information about that data set. You can see what are the different types of data types of available and what are the non null values, that is, are there any empty values, those are also visible here. If you want to see how many empty values, then you can also have a function that is our data frame dot is na, that represents not available, dot sum, find the sum of all such not available values and print. You can see this represents this column related not available values. So currently there are no not available values of this type, so that's why zeros are getting. For each and every column, there is a no null value, that is, there is a no not available values, so that's why zeros I am getting. Okay. Now let's say I want to see particular column related null values, like how many not a null value, that is nothing but you can say if the record is not available, that is missing data. If you want to see the missing data, this is the whole for a whole csv file, then this is the method is na dot sum. Whereas if you want to see the missing data in particular column, then you can use this method, and you also have another method. I want to show you both. So d of type will provide me a particular column related data. This column related how many null values are there, that I want to see. So for that is na dot sum is one method, or okay, let it go. Yeah, 0 we are getting, that means no null values are there, or else is null dot sum. So that also you can able to use to see a single column related null values. Okay, now we have loaded our data set. You can see we have loaded our data set by using pandas, and we visualize, or we just seen the data set related information description and how many null values or missing values in my data set. Okay, now I do not have any missing values in my data set. Now let's say let's display the data set that we have. D. Let's say I want to display only top 10 records. I think this head will display only top 5 records by default. If you want to display top 10, then you can write 10. You can see 10 records will be displayed. Okay, now for me, top 3 records is also enough for me. Okay, now you can observe the type. So let's take some more. Only white is visible here. I want to know like how many records are white type and how many records are another color type. So that I want to see, like I want to group this type. That is I have data set D, right? Yes. I want to group all the values by based on the type, this type column. Based on this type column I want to group all the records. You can see we got a data frame. So dot size will provide me, actually I think, yeah, dot size will provide me how many records belongs to what type. You can say I have totally two different types of wines are there. One is red and another one is white. On red color type wines I have totally these many, and white color wines I have these many. I think this is not looking so good. I want to see this data in the form of data frame, so that's why I'm writing this pandas dot data frame, so that this data will look a bit, yeah, you can see it looks like a data frame. Now it will be looking a bit better, right? Yes. So now in this way you can able to see how many different types of values are there, and such a type of values how many records are there, that you can able to group. That is, you can able to group by particular column related, variable related count. Now by using this group by method in a particular column we can able to identify what are the different categories. So if you want to identify different categories of records in a column, then this group by method is useful for you. Then this group by method is useful for you. You can see this d dot group by of that column name dot size. You can use this to identify the total number of different types of categorical data present in that column. Let's say in this quality column I want to see what are the different types of categorical data is there, and how many types of how many records are belongs to that category. For that d dot group by, I want to provide this quality. I want to see that is how many qualities of wines are there, that I want to see based on size. You can see quality 3, 4, 5, 6, 7, 8, 9. Only these qualities of wines are present in our data set, and that particular quality related wines also you can see the count of that quality wines, how many are there, is visible here. I want to see this in a beautiful data frame format, so that's why I'm using pandas pd dot data frame and rerunning this. You can see, wow, it is visible like good. Okay, now can I say here, since this is not an integer and there are multiple categories of data, before providing this data to my model, do I need to arrange this, or do I need to convert this? Yes, definitely we need to convert this into numerical data before training or before providing this data to our model. So that's why I'm using, I just want to remove this, or so for this type, let's say I want to add one more column, that is a day of white, where this day of white need to remember like whether the wine type is white or not. If the wine type is not a white, then we can easily say it's a red color. So that's why I want to create one more column with white, and there I want to remember this type of wine, that is the color of wine. So how can you able to generate, I think the spelling, yes, it's correct only. I want to generate that data. So for that, you can use pd dot get dummies. Like in pandas, I have this get dummies method. So there we need to provide the data d of, so where this data is present in this a type variable. So d of type will provide me the data, comma. I don't want first column, like it will, this d dot dummies data will provide me two columns. First column is that red colored data and white colored columns data. Among those, I just want white color columns data to be stored in this d of white. That means one more row we will get, one more column we will get with the name white, specifying that whether that particular record is belongs to white wine or not. So that's why I'm dropping that. I'm just going to drop that first value is equals to true. That means our first record will be dropped. Now I want to see the data present in my D. You can see a white column is added with whether the type of the wine is white, then it will be 1, otherwise it will be 0. Okay. Now instead of this column, while training my model, I will pick this data. I will use this column. Okay. Now I can say my data is available, where what is my output that I am expecting, this quality is my output. So I am taking y variable, and d of this quality represents my output. And so what is my input data, that is x. So other than this type and quality, all the records I want to take as input records. So for that how can I able to take? So simply I want to use d dot columns method in order to see what are the columns I have. You can see all the columns are visible, and I want to use dot difference of some list I want to provide, like what are the columns that I want to remove. The columns that I want to remove are nothing but two columns. One is a type column, that I want, that I am specifying here, and one more column that is a quality, that also I am specifying here. And now you can see I'm running this. You can see the both columns will be removed, like whenever I return this a difference method, you can observe that. So first, if I write this a d dot columns in my data frame, what are the columns are there, those all columns will be available here to me. Whereas if I write d dot columns dot difference of, so whatever the columns that I want to remove, those like the type and this quality that is here, and if I run this, then those columns will be removed, and except that whatever the other columns are there in this D data set I got. Now I want to load this, right? So whatever the data present in this, so that I want to take it as, that is only those columns of data I want to take it as the input, right? Yes. Now in this data, do I have this type column? No. And do I have this quality column? No. So now I want to use this data as input. So capital X is equals to this, nothing but our input data. I am just running this by just clicking on shift and enter. So now let's print this x comma y, or x, this is how the x will be, and the output, that is this, nothing but our quality, right? Yes. Okay, now I want to use this data for training as well as testing, or to train my model I want to use this data. So for that, I want to split my data into two parts, right? So for training as well as testing, I want to split my data. Let's see how to split our data into two parts. By using sklearn dot model selection, we need to import train, test, split function, and we need to split our input and output by using this method, that is this train test split method. And we need to provide like a test size. So what is the test size? That is nothing but a testing data set size. That is, we are splitting this data into training as well as testing. So what is the quantity, how much percent you want to use for testing? Let's say I want to use 0.3, nothing but 30% of my data set for testing. And so at last, whatever the result that I'm getting, that I want to store in training as well as the testing data. So x train and x test comma y train and y underscore test. Yeah, so in this I'm storing now. So let's run this, so that in this x train and yeah, this L got run. So in this x train and x test, the data set will be loaded. In similar to that y train and y test also, the data set is splitted and loaded. You can just see that info, like to see how many records are present in this train data set. So totally you can see, or you just run this x train. So let's remove this info to see how many records are there. Totally these many rows are there. And if you see that test records, x test records, or input text records, test records, you can see 1950. So totally that is a, you can say approximately 30% of the data is feeded into x test data, and 70% of data is feeded into x train data. Similar to that, y also looks the same. Yeah, here the length will be 4000 something is there. Yeah, 1000 something is there. So for training and testing, the data is splitted in respective way how you provided this test size. So this 0.3 represents 30% of data is split into test test size. Okay, now we splitted our data into two ways, that is a test data as well as a training data. Now let's train our model and evaluate our model. So to train our model, we need to import our regression based model where it is present. It is also present in sklearn dot model linear model. I'm importing this linear regression, and yeah, you can see this is the correct spelling for linear regression. And now I want to load that model into m variable. So remember, we just loaded right now the algorithm into this m variable. If we print this, then you can see our model related algorithm is available here. Now I want to train this and store this in historical variable h. M dot fit is the method that we are going to use to train our model by passing the input features x train and output expected features y train. Then now you can see h to see our model or trained model, or you can type m to see the trained model. Now We have taken this linear regression model and we trained our model with training data set. Now what we are expecting is we want to evaluate the model. Evaluation, how can we able to perform this evaluation? To perform this evaluation, since what type of model it is, it's a regression based model. Since it's a regression based model, we have an options like a R2 score to see the performance. For performance we can able to see by using this R2 score. Whereas let's say I want to see the number of errors or the errors related response, then how can I able to see that score? By using a mean squared error, you can able to see that score as well. So now let's do these two tasks, like let's perform these two evaluations. So where this R2 score is available to me, this R2 score actually available to me. So let's take a testing data set. So what is the testing data set? Y x underscore test is the testing data set. Now let's use the model to predict the test data. Like let's use our model and predict the output of our test data. M dot predict of this test data will provide me the predicted value, y predicted value for our test data. For our test data, this is the predicted output. Whereas our actual output is present at where? In this y test data, our actual output will be. This is the predicted output text test. This is the predicted test data. We will take this predicted value as well as the original y test data output, and we will identify this performance score as well as mean square error. So to identify this R2 score or mean square error, we need to import those methods from sklearn dot matrix. You need to import that R2 underscore score and mean squared error also present in this. Yeah, we just imported these two methods. Now I want to identify the R2 score between the predicted as well as the original one. So for that, R2 underscore score of y underscore predicted test data to y test, that is original data. I am identifying this R2 score. I think we need to provide the original value at first. Then we need to pass the predicted value to see the performance. You can see, I think the performance is a bit less. It is near to zero. That means our model is performing or not good for predicting the output. So let's see the mean square error as well. Mean squared error. So mean square error of our model by using this original value that is expected and what is the predicted. You can see, so it is a 0.54, that is a lot of error because mean square error is present in between 0 to 1. Since it's not near to 0, that is greater than 0.5, we can say a lot of mean square error is identified in our model. So in this way we can able to predict or evaluate our regression based models by using this R2 score and mean square error. So since we identified the R2 score and mean square error, we can able to take another type of models. Like since this is a regression based task, we can able to take another type of models for that task, and we can able to see the R2 score, that is performance matrix, performance score, as well as this mean square error for multiple models that are already available, and we can able to use particular model which is having very high R2 score, that is a very high performance, and less mean square error, that is less errors through that model, then that we gonna use for our real time purpose. So this is how you can able to use your model, regression based model, and evaluate regression based models in real time based on your data set. So that's all about this video. In this video, we have done pre-processing of our wine data set, and so pre-processing involves a few things like that is this not a none values, that is what are the null values in a column that we have seen, and we have also seen different categories which are present in a column, and particularly for that category how many records are there, that count also we have seen. Particular to that category how many count of records are there. So in this example we have seen, so how many white wines are there and how many red wines are there, so that related that count we have seen. Then we have created a model, ML regression model. We trained our model, then we evaluated our model based on these two parameters like R2 score and mean square error. That means we have evaluated our model based on the performance as well as the errors, and we identified how much better our model is performing. In this video we have understood all these things. I hope you understood this video and you got some knowledge or knowledge recap from this video, and I hope this video is useful. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.